Hello, this is Group 12 with our data mining assignment, Bus Delay Prediction using Transit Information. The data for this assignment was collected from the Dublin Bus RTPI service provided by Dublin Bus. Now these are some of the endpoints provided by the Dublin Bus RTPI service. Now we retrieve these using a SOAP UI, and see now these are the responses we have retrieved. We retrieve this using a batch processing Java application that periodically collects data and saves it to an SQL database running on cloud. And now this is a UI provided by the application through which you can view the data being collected. And all this data is stored into an SQL database. And these were the different tables available: get, destination, real-time data, route, which gives us the different results of the route. And flow processing was done using Tableau Prep to merge them into a single file that can be processed together. And this the merge file was uploaded into BigQuery, and this is our BigQuery table. And these are in BigQuery we have cleaned and removed redundant data. This is our data before cleaning, and we have about 22 million records. And this is our data after cleaning. This is strip data cleaned, that is our database with clean data. This is our clean data table. The next step is feature engineering and applying predictive models. Here we have loaded the data from BigQuery, and then we have applied some preliminary data engineering. We have encoded outbound as 1, and we have divided aimed arrival time into day of the week, hour of the week, such that we can use it in our prediction. And then we have imported the different libraries, and this is our table. Next we plotted the correlation between the different attributes, and now we have performed some label encoding to convert the categorical data to numerical data. And now we drop the redundant columns because we have already encoded some of the columns, so we are dropping the original ones. And now we plot the correlation with the new label encoded columns. Next we split the data into training and testing, and now we perform a basic sanity test with linear regression to get a feel of the data. And then we applied the SVR model, and we applied grid search CV to find the optimum parameters. And we can see C is taken as 100, gamma 0.001, and epsilon is equal to 1, and it gave us an accuracy of 28%. Then we applied the XGBoost model, and we got accuracy of 68%. And then we applied a random forest model, and we got an accuracy of 66%. And now we applied some feature engineering. We have multiplied some columns and created new columns. And this is the new correlation map. And now and these were the results. This is before the feature engineering, and this is after feature engineering. Thank you. We downcast variables to 8-bit because the synthetic variables that we have obtained after multiplying the columns are too big and might cause an overhead on CPU. And downcasting is done in such a way that it does not hamper the results, and that's how we have done our feature engineering. And now, since we have engineered new columns, we drop the original redundant columns, and this is our table, and we have plotted the correlation map again. And now we again split the data into training and testing data, and on the feature engineer data we perform a basic sanity test with a linear regression, and then we applied SVR model, and we got an accuracy of 54%, which is a very big increase in accuracy after 28%, which was before feature engineering. And in XGBoost, we got an accuracy of 69, which is the best accuracy, and we got an increase of about 1% from before feature engineering. And in the random forest regressor model, we've got an accuracy of 66%,